All right, so I want us to look at an example from your book in your textbook on a calculation for kinetics. And so I've given you some introductory things to look at. I sent over a video that I made previously on integrated rate laws, and so we're going to back up just a little bit and do one practice problem together on how that you take a reaction and talk about how that its concentration is changing. And so you should have gotten that from the previous lessons on kinetics, is that when I look at the way that reactions proceed, our concentrations are changing, and so therefore that is how that we're looking at the kinetics of the problem. Kinetics being how fast are those reactions proceeding, and therefore how is my concentration changing. And so what we have here is a data table that has your initial concentrations of both of your reactants and then the rate. And you'll notice that this rate is your concentration per minute. And so this is how that this concentration is changing every minute the reaction is going through. And so, like I said, this is the first practice problem we're going to do together. I would highly suggest that you go through and try to do number 30 on your own when you have watched this video. And so to make this go through a little bit faster, what I've done is I have worked it out together, or I'm sorry, in completion on my own. And so I just want to talk about each step, and then that way you can use this video to go through and actually look at how that you yourself would solve this problem. So number one, I've talked about what the data table is showing us. And so the first part of this is asking us, what is our rate law? Or, like, what is this overall reaction actually saying about how the concentrations are changing? And so what I did, I started off with what my reaction was. And so this is just copying off. This is the rate, the rate of the reaction. And this is how is your chlorine changing per time. And so we're looking at the chlorine gas going away. That's why we have a negative over here. And so what I did, just for my own peace of mind, how I like to write things out, that allows me to think about them. I have my data table written out here just so that I could look at it and really get a feel for what I was actually wanting to look at. When we look at a rate law, it's very important for us to look at how the concentrations are changing. And so the very first thing that I want to do is I want to look at how are each one of these reactants changing inside of the rate law. And so the very first thing that I myself look at when I try to do rate law calculations is, of the 3 experiments that I have, do I have any concentration of one of these reactants that is staying constant while the other one is changing? And so if I do that, I can look at experiment 1 and 2, and I can see that NO concentration is staying constant, but I have a change in the chlorine. So that tells me I can use the data from experiment 1 and 2 to talk about how is my chlorine going through this rate of reaction. So let's do that. I wrote out here for you that I'm going to look at experiment 1 and 2. NO is not changing. 0.1 and 0.1 in experiment 1 and 2, but my Cl2 is doubling. So that way I know that there's a change in that concentration, and I can algebraically go through and figure out what the order of that reaction is, what is the order of Cl2 as it goes through this reaction. So from the first part of your chapter, this is how that we're writing the rate law. For this, the rate is going to be equal to K, concentration of my NO, raised to an X, concentration of Cl2 raised to Y. My whole purpose to find the rate law is to find out what the values of the X and Y are going to be. So, I made a mistake when I was doing this, so I corrected this. I'm going to put experiment 2 over experiment 1 for comparison. I want whole numbers here. That's why that I want to make sure that 2 is over 1. So as I look at that, I take the rate law, and here again, I'm writing everything out just so that I can follow along. I'm going to go over and I'm going to plug information in from my data table. So rate equal to K, concentration of NO raised to the X, concentration of Cl2 raised to Y, over data from experiment 1. So my rate law value equal to K, concentration of NO raised to X, concentration of Cl2 raised to Y. So here, if I'm looking at the way that this is here, and the whole reason I'm doing this is so that I compare the two experiments to see what change is taking place, I can see, well, it's the same exact reaction, so K cancels out. My concentration of NO is unchanged, so that algebraically is going to be a 1, so I'm just going to go ahead and mark that out because it's unchanged. So then that leaves these two right here for me to do the calculation with. I can do this quick in my head. This is 2. 0.2 divided by 0.1, that's also 2. So you could do fancy clicks in your calculator to figure out what x is going to be, but what do you think x is going to be? Well, 2 would have to be raised to 1 in order to get this a value of 2. So that tells me that Cl is the first order. Okay, we're going to do the exact same thing now. We know what the order of Cl is. Now let's figure out what the order of NO is. Here again, looking for unchanged of Cl, looking for a change in the concentration of NO because I'm wanting to solve for NO. So in order to find the order of NO, I'm going to look for a constant Cl, but a change in the concentration of NO. That leads me to look at experiments 2 and 3. So here again, rate law. Rate is equal to K, NO raised to X, Cl raised to Y. I'm going to compare those two just like I did at the top. I'm going to plug in the values of experiment 3 all the way across, experiment 1 all the way across. Okay, so here again, is it the same reaction that I'm looking at? Yes, so the rate constant is going to be the exact same, so that's going to be a value of 1. Can mark it out. My concentration of Cl2 is unchanged. So algebraically, that's going to be a value of 1, so I can mark it out. Isolates the rate and the concentration for me. So in my calculator, if I do this, get a value of 4. In my head, 0.2 divided by 0.1 gives me 2 raised to that x value. So I can do fancy clicks in my calculator, all those kinds of things, but if I were to look at the value of x, I would get that the value of x is 2 for NO. So what does that tell me? Well, all of these things, that tells me that my rate is equal to K, NO raised to the 2, because my value of x was 2 when I did the concentration comparison, Cl raised to the 1. Now this, in my mind, I'm kind of thinking like, what else could be asked of this question if this were an AP free response question or some sort. Not only could it ask you what's the rate law, because that's my answer, I just calculated that. Could also say what's your overall rate, and so I guess I could add that in. Let's just for fun call this AI, overall rate of the reaction. Well, I've got 2 and 1. So the overall rate of my reaction is going to be 3. So just in case that's asked, that's just something else that we could add in there. All right, kids. So one of the things that you're going to learn from doing these more often is that it is very, very easy to get into the groove of looking at this and how data is presented, that you could actually do these in your head if you really wanted to. And I'm sure there's lots of people out there that are smarter than me that are going to watch this at some point, you guys in my class included. If I were to look at the comparison of these initial rates, I could have figured out that that was 4 times greater, or that was twice as great, those kinds of things. And then I could figure out over here that this was a value of like either 2 or some other number it could be in another experiment. I mean, you can get to where that you can look at those and spot check those in your mind and go straight here and straight here instead of having to do this calculation. I mean, that's just a possible option. You know me, I'm a little bit OCD about showing my work. I want to verify that I've got everything right, and so that's why that I go through those calculation steps there. All right, so carrying on with number 29. What's going to happen if we are asked to look at what the value of the rate constant is going to be? So the values that we're going to use to find the rate constant, we are getting from that data table. Like I said, in number 29, it's right here. I wrote it on my own paper just because I'm a weirdo, I guess. But if I were to look at this data, I'm going to use the values from that data table to fill it into my rate law that I've already written. So this is my rate law that I just came up with. And so what I typically do when I'm going to calculate the value of the rate constant, I usually use experiment 1. It's not going to matter. It's all the same exact reaction. Experiment 1, 2, and 3 are all the same reaction. It's all going to have the same K value. So, but, you know, just as general purpose, I've always used experiment 1. So I'm going to use this rate law. I'm going to take the information from experiment 1. Let me see if I can shift this over. Okay, so I'm going to take the information from experiment 1, and I'm going to plug it in. Then I'm going to solve algebraically, and I usually do my units later. You can do your units first. The kids that are in my class that are watching this are probably fainting right now because they think, oh my gosh, she's not telling me to put units in yet. But sometimes the units get really messy when you do rate law expressions, and so I always save them till the end. So I'm going to go ahead and just plug in the numbers. Of course, if you do this squared, and then you multiply in this value here, for this particular expression, you get 0.001. And so, you know, like I started out with just that. And then it says, you know, algebraically solve for your K value. So what would that be? Well, I would take this and divide it over to this other side, and that's what I did there. All right, so when I get here, I actually got down to this portion here, and I just wrote that 0.18 divided by 0.01 was 180, and then I stopped because then I want to go through and I will look at my units. Okay, so see if you can follow this scribble. When I started out, I'm looking at the units of what my NO concentration is and my CL concentration. Once I got there, I knew that they were molarity, so moles over liters. The NO concentration was second order. The CL concentration, or CL2 concentration, was first order. So I'll plug that in. Second order, first order. So what did that tell me when I did the overall concentration, just like it would be up here? What would my units be just for this right side of the expression beside K? Well, if I multiplied across, it'd be moles cubed over liters cubed. Okay, that's awesome. Now I got to figure out, though, what is my units for my rate? Well, if you look back at your data table, it is moles per liter per minute. So, I'm starting here. Then, remember, I was up here, molarity per minute divided by moles cubed over liters cubed, or molarity cubed, whatever you want to say. If I'm dividing by those, this is what it looks like. Moles per liter per minute divided by moles cubed over liters cubed. So, remember, you're going to divide by this fraction, which means that you're going to multiply by the reciprocal. So, here I am. Moles per liter per minute multiplied by, now you put liters cubed on top, moles cubed on the bottom, and I'm going to multiply across. Let me zoom in here. Okay, so now what did I do? Flip this. All right, so not insulting anybody's intelligence here. I just want to make sure that you follow along. If this originally was liters cubed, and I have a liter down here on the bottom, liter, and then this cubed turns this into a 2. If this was moles cubed, and I have a mole up here, that changes this to squared. So what does this become? If you're looking at it overall, liters squared over moles squared. And did I do anything to this minute? No, I did not. And so that's how this is the overall unit. Now, I have seen tricky AP questions to where that they say, just what's the unit of your rate going to be? I mean, they just want to know that you can follow along and do this unit stuff here. Okay? So, I mean, I've seen questions like that. You know, like the AP questions, they have like, I don't know, 18, it feels like, portions to them. I have seen several questions, before, to where that it has you to, write your rate law like this. And then they'll say, what's your overall rate? And you're like, okay, no big deal. And then they'll say, okay, and then at the very end, what is your expression, or what is your units for your rate? And so this essentially is all they're wanting you to do, is to just be able to multiply by your reciprocal and take all of those things and put them in for your rate. So, your rate constant. So when we're looking at this, the units for that rate constant, this can very well be one question that you have on that free response question. Like I said, this is the first installment of step-by-step of how to do calculations for your rate law. And for your initial rates. So if you would, in your book, if you're in my class, I want you to try this number 30. Message me if you have questions on this. I'll be able to go over the integrated rate law with you tomorrow. Thanks for watching.